Okay, welcome back everyone. What I'd like to do today is finish up 5A, section 5A. Remember 5A, we started it last time. It really consists of 4 sections in chapter 5, right? It's 5.1, 5.2, 5.3, and 5.4. So in the last video lecture, I covered 5.1 and 5.2. So today I want to cover 5.3 and 5.4. So section 5.3, this is on basic concepts of polynomials. So I need to define exactly what a polynomial is. But before we do that, I'm going to define something called a monomial, which is really a polynomial just of a single term. So I'm going to start there and we'll kind of build up from there. So a monomial is an expression that is the product of a real number and variables raised to non-negative integer powers. So, and variables raised to non-negative integer powers. Okay, so an example would be the following. Actually, I'll give you several examples. So something like, say, -3, that's my real number. And then I have some variables, and the exponent is always a non-negative power. So say 2, 3. That would be an example of a monomial, okay? Or, something like 5x, right? Remember, x means x to the 1 power. That would be a monomial. 3xy. Or even if I just do x squared y. So now the thing multiplying in front is a 1, right? Even a constant, like if I just do 8, this is also a monomial, right? You could think of this as, if you wanted to, you could write 8 as 8x to the 0, right? So then the exponent would be 0, which is still non-negative, right? It could be 0, but we never write that. We would just leave that as 8, right? So we'd leave this as 8. So a constant is also a monomial, right? Those are all examples of monomials. Now, what is a polynomial? So a polynomial is an algebraic expression with one or more monomials added or subtracted. So is an algebraic expression with one or more monomials added or subtracted, right? Added together or subtracted. So again, what does that mean? Well, let me give you some examples. So here's an example of a polynomial. Say 2x squared, right? So that's a monomial. minus 5x, I'm subtracting another monomial, plus a constant, which again is another monomial. So a bunch of monomials that are added and subtracted together form what's called a polynomial. Other examples, I could have, say, 4m, I'm using m now as my variable, 4m cubed minus 5. That would be a polynomial. Even a monomial by itself, so let's say 7x squared, that's also a polynomial, right? It's a polynomial of a single term. So the monomial is also a certain type of polynomial. It could be more complicated, right? You could have, in all these cases right here, I have one variable. So the first polynomial has just x, second one has just m, third one has just x. But you could have a polynomial in more than one variable. So say two variables, let's say p and q. So this would be an example of a polynomial. Happens to be in two variables. But this is not, right? So let me note that here. This right here is not a polynomial. Why is it not a polynomial? Because one way I could write this, I could bring that x, remember we learned this rule, if I bring the x from the denominator to the numerator, it's going to switch the sign of the exponent. And we said that in order for it to be a monomial, that the exponent cannot be negative, right? It has to be non-negative. So that would not be a polynomial. So you just have to make sure you either have a constant or you have a variable to a positive exponent. And then it would be fine. But anytime you have a negative exponent, it's not a polynomial. All right. There's a couple of ways we can classify polynomials. We can either do it by number of variables, which I just discussed a little bit, and then number of terms. So let me talk about that. So classification of polynomials. So one way is by the number of variables. So for instance, if I have, 5x squared minus 7x plus 4, this is a polynomial, and it's a polynomial in one variable because the only variable that exists in that equation is x, right? So this would be a polynomial in one variable. Let's say I had something a little different. Let's say I had 3x squared. I'll do actually 3x cubed y squared minus 2x squared y plus x plus 9. So this is a polynomial, but in this case, since the polynomial contains both x's and y's, this would be a polynomial in two variables. Okay, and of course you could have 3 variables, 4 variables, you could have more. I'm just going to stick with 1 and 2. So that's one way of classifying polynomials, by the number of variables. Another way of classifying polynomials is by the number of terms. Okay, so let me move this up a little bit. So I could also classify by number of terms. So if it has just a single term, let's say 5x squared, this is what we already talked about. This is called a monomial. Right? Mono means like one, right? So monomial. If it has two terms, and it can be anything with two terms, let's say, 3x minus 4. So it's a polynomial with two terms. You can probably guess what this is. This is a binomial, right? Two terms, binomial. If it has three terms, let's say this polynomial, x squared plus 9x minus 3. Again, you can probably guess what we call this. This is called a trinomial. And then if it has more than three terms, we don't usually use any special names for this. So let's say it has, 4 terms here. We would just call that a polynomial, right? That's just a polynomial in general. Even though all these are polynomials, but in particular, if it has just one term, two terms, or three terms, they have special names: monomial, binomial, and trinomial. But more than that, we just call it a polynomial. Okay, another thing that's important is the degree of the polynomial and how we write the order of the terms. So degree, let's say degree and order of terms. So the degree, let's start with a monomial first, with a single term polynomial. So the degree of a monomial in one variable and we're going to focus on polynomials mostly just in one variable, is the power of the variable. So basically what it's saying is that the exponent tells us the degree of that monomial. So for example, let's say my monomial was negative 7x cubed, right? Then what's the degree of that monomial? It's a third degree. And I just have to look at that exponent to determine that. So it's third degree. Let's say my monomial was negative x. Well, remember, you can think of this as negative x to the 1, right? We never write that 1, but there's really a 1 there. So this would be a first degree monomial. And then if I have just a constant by itself, 9, right? Remember, we can think of this as 9 times x to the 0. Because x to the 0, anything to the 0 is 1. So a constant we usually say is a zeroth degree monomial. Okay, so if you just see a constant, it's degree 0. X by itself, or negative x, or negative 7x. If it's x to the 1, it's first degree. And then if it's squared, it'd be second degree, right, to the third power, third degree, and so on. So it just depends on that power, right? So we just have to look at the exponent. So that's for a monomial. What about a polynomial in general? Okay, how do we figure out the degree of a polynomial in general? Well, first of all, let's talk about something called the leading term of the polynomial. So the leading term of a polynomial is the term of highest degree. Okay, so for example, let's say I have this polynomial, 7x squared minus 9x minus 1. What is the leading term? Well, the leading term is the one with the highest degree, so it's the one with the highest or largest exponent. So the leading term in this case is going to be 7x squared. Okay, let's say, let me do another example. Let's say I have this. Let's say I have 2x minus x third minus 5x to the 7th plus x squared minus 2. Right, there's my polynomial. What is the leading term? Well, the leading term is the term of highest degree, so it's the term with the largest exponent. So the leading term in this case would be negative 5x to the 7th. Okay, so then how do I find the degree of a polynomial? Well, the degree of a polynomial in general is just the degree of its leading term. So the degree of a polynomial is simply the degree of its leading term. So if I had something like this, let's say I had 4x cubed minus 5x plus 7, that's my polynomial. Well, what is the degree of that polynomial? Well, the leading term is 4x cubed. So that degree is 3, right? Because the cube, the exponent is a 3. So this as a whole, that polynomial is a third degree polynomial. We only have to look at the degree of the leading term, right, to figure out the degree of the polynomial. Okay, now usually when we write out polynomials, they're arranged in descending order of degree. So usually polynomials are arranged in descending order of degree. So what that means is I would write the term with the highest degree first, then the next highest degree second, and so on all the way down to the constant, if there is a constant, right? So, for example, it's just convention to write it this way. So, descending order. So, for example, let's say I want to rearrange in descending order. I'll give you the polynomial in a second. And I also want to identify the degree of this polynomial. Okay, so here's the polynomial. 5x cubed plus 3x to the 5th plus 8x plus 3. Okay, so first thing, write it in descending order. So the largest term is 3x to the 5th. Then I have the next largest, looks like is x, 5x to the 3rd. Then it looks like it's 8x, and then 3. So that's the first part, right? I rewrote it in descending order. Now, what is the degree of this polynomial? Well, now it's just the degree of the leading term, but since I wrote it in descending order, that's just the degree of the first term, so this must be a 5th degree polynomial. Again, how do I know that? From this, right? From the exponent of the leading term. So that's pretty straightforward, right? So you just write in descending order. The degree of the polynomial is just the degree of the leading term. And that's it. Okay, what if we want to simplify polynomials? Okay, let's say I'm asked to simplify this polynomial, x cubed plus 5x minus 7x squared minus 1 minus x cubed plus x. How do I do this? I just have to combine like terms, and then usually you rewrite the polynomial in descending order. So I'll say just combine like terms and write the final answer in descending order. Okay, so let's look at this. Well, I have a 1x. Remember, a like term is going to be the variable, or there can be more than one. In this case, there's only one variable, right? So it's a polynomial in one variable. It's the variable to the power. Those have to match. And in this case, I have remember there's a 1 here, right? So 1x cubed minus 1x cubed, those are gone, right? It happens to be 0. Then the next highest term is negative 7x squared. So I'm going to x that out. So I have that. So it's negative 7x squared. Then it looks like the x's, right, the linear terms. So I have positive 5x plus 1x. That's going to be plus 6x, right? So I combine those two. And then I just have the one constant here, the negative 1. So that would be my answer. So all we're doing when simplifying is we're combining like terms. Here's another example. So let's say it's 6n cubed plus 20n minus n squared plus 2 minus 4n cubed plus 15n squared plus 8. So that's my polynomial, and I want to simplify it, right? So look, what's the terms of highest degree? It looks like third degree, right, is the highest. And I have a 6n cubed and a negative 4n cubed. So what's 6 minus 4? It's 2, right? So this is 2n cubed. So I combine the n cubes together. Now my next highest is n squared, I guess, right? So I have a negative 1n squared plus 15. What's negative 1 plus 15, or 15 minus 1? That's 14. So this is going to be 14 n squared. Then let's see. Oh, it looks like I have an n, just one term, right? Plus 20n, so I can just write that down. Plus 20n. There's no other n's. I don't have to combine anything. And then the constants, 2 plus 8 is 10. So that simplifies that polynomial. And again, I rewrote it in descending order. Okay, so all you have to do to simplify is combine like terms. Now, another thing you might be asked to do with polynomials is to evaluate them. And we kind of did something like this in chapter 2. Let's say we want to evaluate this polynomial, 5a plus 11, for, say, a equals 2. Okay, well, all that means is you go to the polynomial, right? Go to that expression, and where you have an a, you're going to plug in a 2. That's all you're doing. You're just substituting in that value. And then make sure you use order of operations, right, to find, to expand it out, to solve this. So I need to do multiplication first, right? So 5 times 2 is 10. And then 10 plus 11 is 21. So this would be equal to 21. That would be the answer. Here, let's do another one. So this is nothing new. We actually did this in chapter 2. We just didn't realize we were dealing with polynomials, right? So let's say we're asked to evaluate 3y squared plus 2y plus 1. And let's say I want to evaluate it for... I'll do two separate problems for y equals 2 and then later for y equals -1. Okay, so let's do y equals 2 first. So I go to that expression, that polynomial, and where I have a y, I'm going to plug in a 2. Remember, this is being squared. Okay, so the first thing I would do is the exponents, right? So 2 squared is 4. I'll just write everything else down again. Then I have to do multiplications. So 3 times 4 is 12. 2 times 2 is 4, plus 1. And then I can add left to right. So 12 plus 4 is 16 plus 1. This is going to be equal to 17. Okay, so if I evaluate that expression, that polynomial when y is 2, I get 17. And then to do the same thing for -1, I just plug in -1, right? But you have to be careful because now I'm squaring the entire -1. Here I'm multiplying by -1 plus 1. So what is -1 squared? Well, now the square, the 2, is acting on the entire -1. So -1 squared, I'll do it on the side here. Oh, let me erase that. So -1 squared. This means -1 times -1, which is a positive 1, right? Because I'm squaring the entire thing. So this is now really 3 times 1 plus 2 times -1 plus 1. Now I can do the multiplication. So 3 times 1 is 3. 2 times -1 is -2. And then 3 plus -2 is 1. And then 1 plus 1 is 2. So that's equal to 2 in this case. So if I evaluate that polynomial for y equals -1, I plug in -1, and ultimately I'm going to get 2. And you just have to be careful with order of operations. Okay, great. Actually, that's it for 5.3. Now I want to talk about 5.4. And 5.4 is on the addition and subtraction of polynomials. And basically, it involves what we just talked about, combining like terms. Okay, so 5.4 is addition and subtraction of polynomials. Okay, so to add polynomials together, just add like terms. So I'll say to add polynomials, just add like terms. So for example, right, if I have, say, x squared plus 3x minus 8, and I want to add that to, say, 10 minus 3x plus 4x squared. Well, the way I like to think about this is, first of all, since I have just a 1 out front, like if there's nothing written out front, remember there's always an implied 1 there, an implied 1 there. So if I distribute in that 1, it's not going to change anything. So basically I can remove the parentheses and I'm just going to have this one large expression. And now I'm just going to combine like terms, right? So I have x squared plus 4x squared. So that's going to be 5x squared Then I have, let's see, the x's are next, right? So 3x minus 3x. Actually, that's nice. That's 0, right? So that's gone. I don't have any x term. And then negative 8 plus 10 is a positive 2. So that would be the answer to my addition. It would be 5x squared plus 2. Okay, here's another one. Let's say we have 2x cubed minus 4x squared y plus xy squared plus y cubed. And I want to add that to 3xy squared minus 6. And I want to add that to 2x squared y minus x y squared minus 2y cubed plus 3. So I want to add those three polynomials together. Now, it's a little more complicated, right? Because these are polynomials in two variables in both x and y. But the idea is the same. Because I'm adding everything, and I only have a 1 right in front of each of those parentheses, I can remove the parentheses. So I'm going to write this again where I remove all the parentheses. So I have, let's see if I can fit it in here, 2x cubed minus 4x squared y plus x y squared plus y cubed plus 3x y squared minus 6 plus 2x squared y minus x y squared minus 2y cubed, and then squeeze it right in here, plus 3. Okay, so now I need to combine like terms. So where do I start? Well, it's sometimes not obvious with, especially if you have a polynomial in two variables. So I'm just going to start with the first term. 2x cubed. Do I have any more x cubes in here? Let's see. Doesn't look like it, right? So I guess that's the only x cubed term, so I'm just going to leave it as 2x cubed. Now I'm going to do the second term, which is x squared y. Do I have any more x squared y's? Yeah, it looks like right here, right? So I have a negative 4 x squared y and a positive 2. Well, what's negative 4 plus 2? That's negative 2 x squared y. Then I'm going to go with the xy squared, the next term. So this is a 1, right? A 1 xy squared. I have a 3 xy squared. And then it looks like a minus 1 xy squared. So what's 1 plus 3 minus 1? That's going to be 3, right? So this is going to be 3xy squared. Then it looks like y cubed is next. So I have 1y cubed minus, let's see, 2y cubed. What's 1 minus 2? That's negative 1. Right, so negative y cubed. And then finally, with the constants, I have a negative 6 and a positive 3. So negative 6 plus 3 is a negative 3. So that will be my answer. Right? When I add those polynomials all together, that's my resulting polynomial. Okay? Some people like to do this. I like to do it like this horizontally. Some people like to add vertically. Let me just show you how you could do that. I won't spend too much time on this, but this is another way of doing it. Just another way of organizing your work. You could add vertically. So in other words, let's say you were asked to add these two polynomials. 2r cubed plus r plus 2, and I wanted to add it to negative r cubed minus 8r squared plus 5r minus 6. Okay, so what you could do is you can make a column, start with the highest term, right? So 2r cubed. Then I don't have any r squares in that first polynomial, so I would just leave a space, then put the r, and then put, so I'll do plus r, and then plus the constant. Then in the second one, I have a negative r cubed. I do have a square term, so I'll write it in here, negative 8r squared. And then I have a plus 5r, and then a minus 6. So all we're doing, if you can see here, is lining up vertically, right? We're lining up the r cubes, the r's, the r squares, the r's, and then the constants. So you're just adding vertically. It's the same as if you had done it horizontally, right? Some people like this organization better. So either way, whatever way you find easier, you should do it that way. So 2r cubed minus r cubed, this is just r cubed. So now I'm just adding down the columns, right? 0 minus 8r squared is just still negative 8r squared. Then r plus 5r is 6r. And then positive 2 minus 6 is negative 4. So it's just a different way of organizing your work. Again, whatever way you feel more comfortable with is fine. Okay, and then the last thing I want to talk about is subtracting polynomials. So to subtract polynomials, you change the sign of each term of the polynomial being subtracted. So change the sign of each term of the polynomial being subtracted. Then add like terms, right? Then it becomes an addition after that. So then add like terms. Okay, so for example, let's say you're asked to subtract these two polynomials. Let's say we have 8x cubed minus 10x squared plus x. And let's say I want to subtract 2x cubed plus 7x squared plus 3x. All right, so what this is saying is the first polynomial I can leave, I can remove those parentheses, the first polynomial is fine. If I want to subtract that second polynomial, I can think of it as adding the opposite. So that's why they say change the sign in each of those terms and then add like terms. So remember subtraction in general, we're way back in chapter 1, you can think of subtraction as adding the opposite. So it's the same thing here, right? If I do a minus b, that's the same thing as a plus a negative b. I add the opposite of b. And the opposite means change all the signs in that polynomial. The other way to think about this, and I think maybe this is the better way, this is the way I like to think about it, is think of that subtraction. I'm going to rewrite this. Remember, you can think of this subtraction as plus a negative 1, and then I still have the second polynomial here. So what do we need to do first? We need to distribute in that negative 1, right? So I need to multiply every term by negative 1. Well, what does that do when I multiply every term by negative 1? It changes the sign of each term in that polynomial. So that's why you change the sign, because you're really distributing in a negative 1. The first polynomial is fine, right? Because I just have a positive one out front here. So I can just remove the parentheses and write this as 8x cubed minus 10x squared plus x. But then the second one I have to distribute into negative 1. So negative 1 times 2x cubed is negative 2x cubed. Negative 1 times 7x squared is negative 7x squared. And then negative 1 times 3x is negative 3x. Now I can just combine like terms and I'm done. Right, so I'm just adding like terms, combining like terms. So I have 8x, I guess cube terms are my largest, right? So 8x cubed minus 2x cubed. So 8 minus 2 is what? 6, so that's 6x cubed. Then squared terms, I have negative 10x squared minus 7x squared. So negative 10 plus a negative 7 is negative 17x squared. Then I have plus x minus 3x. Well, 1 minus 3 is negative 2x. So that would be my answer. Okay, let's do some more examples of this. Let's say I have this now. Let's say I have 8p to the fourth minus 3q to the fourth. So that's my first polynomial. And when I subtract p to the fourth minus 7p squared q squared plus q to the fourth. That's the polynomial I want to subtract. Okay, so again, the first polynomial is fine, right? I can remove those parentheses. I can just write this out. 8p to the fourth minus 3q to the fourth. For the second one, I need to distribute in this negative 1. Right? Because I can think of it as plus negative 1 times that second polynomial. So I need to distribute in that negative 1. But again, what does that do? It just changes the signs. So this is going to become a negative p to the fourth. Right? Negative 1 times positive p to the fourth is negative p to the fourth. Then negative 1 times negative 7p squared q squared is positive 7p squared q squared. So again, it just changes sign. And then negative 1 times q to the fourth is negative q to the fourth. And now I combine like terms. So it looks like I have 8p to the fourth and then negative 1p to the fourth. So that's going to be 7p to the fourth. Then I have, let's do this term next, the p squared, q squared. There's only one of them, right? So I'll just write that down. So plus 7p squared q squared. And then negative 3q to the fourth minus q to the fourth. So that's a negative 1q to the fourth, right? So negative 3 minus 1 is negative 4q to the fourth. Great. Do a couple more. Let's say I have this. X squared plus 2x minus 6. So that's my first polynomial minus 10x plus 7. Okay, so first, remember there's a negative 1 there. First polynomial is fine. I can just remove the parentheses. For the second one, I can think of this as plus a negative 1 times this, so I can distribute in the negative 1. So negative 1 times 10x is negative 10x. Negative 1 times 7 is negative 7. Right? It changes both the signs. Now I just add them, right? Which means combine like terms. Well, there's no other x squared terms, so I just leave that. That's x squared. There's 2x minus 10x. So 2 minus 10 is negative 8. Negative 8x. And then negative 6 minus 7, the constants, what's negative 6 minus 7? That's negative 13. So that would be my answer to that subtraction. And then here, let's do one more, and that'll be it for 5.4. So in this case, let's say I have 2 m squared n squared minus mn plus 7 minus mn minus 3, and then plus m squared n squared plus 7. So I want to take the first polynomial, subtract the second one, and add the third polynomial. Okay. So, well, the first polynomial is fine, right? I can just remove the parentheses. So I have 2m squared n squared minus mn plus 7. For the second one, I need to distribute at -1, right? So it changes both signs. So this is going to be, when I remove the parentheses, I have to write negative mn and then plus 3, right? -1 times mn is negative mn. -1 times -3 is positive 3. And then the third polynomial, since I'm adding it, again, I can remove the parentheses and I don't have to worry about anything, right? Just keep the same terms there. So m squared n squared plus 7. Okay, so now let's combine like terms. Let's see. So m squared n squared. I have 2 here, and what else? Oh, and I have 1 here, right? So that would be 3 m squared n squared. Then mn's, I have a negative mn, another negative mn. Remember, that means -1, right? So -1 minus another 1 is -2 mn. And then for constants, I have 7 plus 3, that's 10, plus 7, I guess, is 17. So that would be the result of adding and subtracting those polynomials together. Great, so that's it for section 5.4. So we're done, we're completed 5A. So actually what I'll do next is I'll create another video lecture to go over the practice for 5A, and I'll post that practice for you guys. And then I will start, within a day or two, I'll start doing the lectures on 5B. And there's only 3 more sections left, 5.5, 5.6, and 5.7. And then we're going to be done all the material for the course. So after I'm done 5B, I will create a solution guide to the practice sheet for 5B. And then I'll give you guys a practice for the final exam, and I will create a solution guide for that as well. But remember, since the course is all online now, all your exams, exam 3 and your final exam, are just going to be exams on My Open Math. And they're going to be 20 questions, very similar to what you're doing for your homework and quizzes, right? So in that sense, you'll know what to expect. In fact, I'm just pulling questions basically from the quizzes, and they're just different numbers, right? But the same exact type of questions. By the way, I changed the format for the exams. Originally, I wanted you guys to do it like within a 3-hour period. Now I'm just giving you 3 chances, and you have to do it by the due date. Okay? So I changed that to make it a little less stressful, a little easier on the exams. All right, I will talk to you guys soon. I will work on the solution for the practice for 5A next.